Hello, everyone. Today we're going to be talking about the binomial distribution. So in order for something to be a binomial distribution, it has to follow bins. So the B in bins stands for binary, means there's two options, success or failure. Independent, the I, means that knowing one outcome doesn't change the probability of the next thing happening. N is for number of trials, so there is a fixed number of trials. You're only doing it a certain number of times. And the S is for success. The probability of success is the same for each trial. So in order to know if something is a binomial distribution, you have to check bins. So here is an example. Rolling a die 3 times, find the probability of getting 0, 1, 2, or 3 2s. So doing this, so it fits bins, it's binary, either you get a 2 or you don't. It is independent because each roll doesn't depend on the one before it. If you get a 2 the first time, that doesn't affect the probability of you getting a 2 the second time. They're both 1/6. We're rolling the die 3 times, so there's a fixed number of trials, and the probability of success is 1/6. So to get 3 2s, you do 1/6 times 1/6 times 1/6, so 0.0046. Probability of getting two 2s would be 0.0231 each separate time, but it happens 3 times. So you got to add all those up or multiply 0.0231 times 3. Same situation with getting 1 2. 1/6 would happen one time, 5/6 would happen twice, 0.1157, but that happens 3 different times, so you have to multiply that by 3. And then no 2s would be this end result that only happens once. So now for problems like this, where you're only doing 3 times, you can draw out a whole tree diagram. But if we were rolling a die 10 times and wanted to find the probability of getting 3 2s, it would be a much larger tree diagram. So we don't want to always go through the work of drawing the tree diagram. So in order to find the number of ways something happens in a binomial distribution is the choose function. So 3 choose 0 or 3 choose 0, there's just 2 different ways of writing it. You'll probably end up seeing both of these. So 3 choose 0 is 1. 3 choose 1 is 3. 3 choose 2 is 3. And 3 choose 3 is 1. So if you notice, it told us these different probabilities. Red happened once, green happened 3 times, blue happened 3 times, and purple happened once. To do that on your calculator, if you don't remember, you go to math, over to probability, and it's N choose R. Let's just do 3 choose 2, and that is 3. So math, over to probability, and then N choose R. If you do remember also, this is a row on Pascal's triangle as well. So if you remember Pascal's triangle, you can just write down, but if you don't, use your calculator to find these. Now the whole probability formula here for the binomial distribution, we basically did everything for it already. And choose R, we did. Probability of success is P. probability of failure is 1 minus p, and how many times you fail. So basically, if we were going to roll a die 3 times, find the probability of getting 1, 2. So n is 3, and we want 1, 2, so r is 1. The probability of getting a 3, p, is 1/6. So the 1 minus p would be 5/6. So filling that all in, it's 3. We want 1 success. So 3 total times rolling 1 success. Probability of success is 1/6. That we want to happen 1 time. And we want to fail twice. So 3 minus 1 is where we get the number of failures. And the probability of failure is 1 minus 1/6, which is 5/6. So if we go back to our tree diagram, what this is doing for us is getting 1, 2 would be all the blue branches. So it finds that probability 1/6 times 5/6 times 5/6. And then it multiplies it by 3. That's the 3 choose 1. Now other formulas for this binomial distribution, to find the mean of a binomial distribution, all you have to do is take n times p. N is the number of trials and p is the probability of success. Easiest way to think about this, if you flip a coin twice, how many heads would you expect to get? So n is 2, p is 1/2. You would expect to get 1 head if you flipped a coin twice. And then standard deviation is the square root of n times p times the quantity 1 minus p. So those are just plugging in to those two formulas when you have a binomial distribution. The last thing are the calculator functions that you can use, so you don't even have to use this big formula. So binomial PDF is finding equal to. So roll a die 6 times, find the probability of getting exactly 1, 3. That'd be equal to. Now CDF is less than or equal to. So if I roll the die 6 times, find the probability of getting a 2 or less times would be an example of the CDF. Now those calculator functions are second vars gets you to the distribution menu. And if you go down, A and B on this calculator are binom PDF and binom CDF. If you pop that up, it'll ask for the number of trials. So let's say 3. Rolling a die 3 times, probability of success is 1/6. And we want 1 success. So then you get your probability. Now CDF on the other hand, so second vars, gets you to the distribution menu. CDF would find, so let's say we did it 6 times. If we wanted to find the probability of getting less than or equal to 3 2s, we would put in 3 there, and then that would be the probability of getting less than or equal to 3 2s.